Hi guys, my name is Xavier Gilbert, and today me and my friend will share to you about chapter 3, apparatus and technique, but we will be more focusing on filtrations and heating apparatus. Even though we always found these apparatus in chemistry lab, they actually play an important role in our daily life, especially in food, waters and medicine. For example, filtration make sure the water and ingredient we consume are clean, and heating process prepare samples and ensure safety and accuracy. So, in this video, we will cover type and use of filtration equipment, heating tools and how they prepare materials, daily and industrial examples, the importance of cleaning and safety, a wrap-up of how these tools protect us. So, let's begin with the science of filtration.
Hi everyone, I'm Arman, and now we are going to talk about filtration. Filtration is a technique that's more important than it seems. Filtration is simply a way to separate solids from liquids. It helps remove unwanted particles or impurities from a mixture. We often use it in chemistry labs, but guess what? It's also something we rely on in daily life, like when we filter water before drinking it.
And now, let's look at the two main types of filtration, gravity and vacuum filtration. We start with gravity filtration. Gravity filtration is the simple one. It uses gravity, just like the name says, to slowly pull liquid through filter paper. This is great when we are working with gentle or small tasks. Then we have vacuum filtration, which is much faster. It uses suction to pull the liquid through the filter paper more quickly. This method is commonly used in laboratories and factories when we need to filter larger amounts or do it faster. So, whether you are using a funnel at home or a vacuum pump in a lab, both types help us keep liquids clean and clear. So we've seen how filtration works in theory, but where do we actually use it outside the lab? Let's look at some real-life examples that connect chemistry to our daily routines. First and foremost, water filters at home. At home, many of us use water filters in our kitchen taps, in filter jugs, or even in portable bottles. These filters work by removing dirt, sand, rust, and even bacteria from the water, making it safe to drink. This is especially important in areas where tap water might not be clean enough on its own. Thanks to filtration, we can drink water confidently without worrying about invisible contaminants. Next, in medicine factories or pharmaceutical labs, vacuum filtration is used during the production of drugs. Maybe ask why? Because medicine needs to be extremely pure and precise. Any small impurity can change how the drug works in the body. So, vacuum filtration is used to remove solids, impurities, or undissolved particles from chemical solutions during manufacturing process, keeping our medicine clean and safe. And finally, filtration plays a big role in food manufacturing too. A great example is cooking oil. When cooking oil is produced from plants like sunflower or palm, it often contains bits of plant material or impurities. These need to be filtered out before the oil can be bottled and sold. Filtration ensures the oil is clear, safe, and good tasting, and help extend its shelf life too. So, whether it's the clean water we drink, the medicine we take, or the food we cook, filtration is quietly working behind the scenes to keep it all safe for us.
Hi everyone! I will be talking about the heating apparatus we commonly use in the lab and how they help in preparing samples for testing. So, why do we need heat in the lab? Heating is essential to either dry, melt, dissolve, or prepare substances for analysis. Whether it's food, soil, or medicine, getting the sample ready properly is the key to getting accurate results. Let's start with the hot plate. Hot plate is used to heat liquids quickly and evenly. For example, if we are dissolving sugar in water for food analysis, a hot plate helps speed up the process without burning the sample. Next is the water bath. This one is gentler and is used when we don't want the temperature to go too high. It's perfect for warming things like milk or dairy samples during quality tests, so we don't accidentally denature proteins by overheating. Now for the oven. In food labs, ovens are used to remove moisture from products like cereal and bread to test their water content. This is important because too much moisture can cause spoilage or affect texture. Then, there is the Bunsen burner. You've probably used this in chemistry class. It gives a strong, direct flame and is ideal when we need to heat something fast and intensely, like during flame test or when sterilizing tools. Finally, the muffle furnace. This one's heavy duty. It burns organic material at very high temperatures and is used in environmental labs, especially to test soil samples for metal contamination after all organic matter is removed. Now, let's move to the real-life example. In food labs, ovens test the moisture content of cereal and bread, as I mentioned, from the tools used. And then in environment labs, heated soil samples are tested for heavy metals. And in pharma labs, heating ensures ingredients dissolve completely, and each tool helps make testing accurate and repeatable.
Hi everyone, I'm Joanne. Now that you've learned about how filtration and heating equipment work in the lab, I'll be sharing something just as important: how safety, cleanliness, and the types of chemicals we use, also called reagents, play a big role in getting accurate and reliable lab results. Imagine performing a food safety test or checking if water is clean, but using dirty glassware or contaminated chemicals. The results would be completely wrong, and that could be dangerous, especially in fields like medicine or food testing. To prevent this, laboratories follow strict cleaning procedures. Common cleaning methods include using warm detergent to remove general dirt, or for more stubborn residues, a nitric acid rinse is often used, especially after heating tools have been used, such as crucibles or tongs. For glassware with strong stains or leftover organic materials, more powerful cleaning solutions like dichromate solution or aqua regia may be used. For fragile instruments like pipettes and burettes, ultrasonic cleaning is preferred. This method uses sound waves to shake off tiny particles without damaging the equipment, ensuring it's clean without risking breakage. Besides clean tools, we also need high-purity chemicals called reagents to make sure our tests are reliable. There are three common reagent grades. The highest is AR grade, which stands for analytical reagent. This is used for very sensitive tests such as testing for toxins in food or chemicals in medicine. Reagent grade is slightly less pure, but still good for general laboratory use. And lastly, technical grade is the least pure, used in industrial processes or where precision is not critical. To keep everything safe and accurate, there are also important lab safety rules. One major rule is to never return excess chemicals to their original containers. Doing so could contaminate the entire bottle. Another important habit is to always use clean equipment, as even a small trace of leftover substance from other experiments can ruin your test. It's also important to label all containers properly and to dispose of waste correctly, whether it's liquid, solid, or chemical. These practices not only ensure accurate results, but also protect lab users and the environment. In summary, maintaining clean equipment and using the correct reagent grade are essential for getting accurate and trustworthy results in any scientific investigation. Whether you are testing if your food is safe, checking water quality, or preparing medicine, these practices make sure the results you get are correct and ultimately help keep people safe. That is all from me, and I'll be passing the baton to the next teammate.
Let's take a closer look at how filtration and heating are applied in the real world, beyond the laboratory setting. First is water treatment system. This multi-step filtration to remove suspended solid, harmful organism and chemical pollutant, making water safe for human consumption. Next is milk pasteurization process. Involve controlled heating to eliminate bacteria such as E. coli and Salmonella, increasing shelf life and protecting public health. In pharmaceutical manufacturing, apply filtration to verify chemical solution and heating to sterilize equipment, ensuring safe and effective medication. In cooking and food preparation, use various heating techniques to kill harmful microbes in raw ingredients, preventing foodborne illness in household and restaurant. Finally is hospital sterilization procedures. Employ high temperature autosave and air filtration system to maintain sterile environment and heat and prevent infection during surgeries and treatment. Fusion filtration and heating may seem like a simple lab technique, but they have a powerful impact in our everyday life. This process helps ensure the water we drink is clean, the food we take is safe, and the medicine we take are free from harmful contaminants. They are also initial in hospital for sterilizing tools and protecting patients from infection. This shows that scientific techniques used in the lab are directly connected to real-world safety and public health. It also reminds us that frequency and care in using this method are extremely important, not just in school experiment, but in industry and environment where people live, being depend on it. By understanding how filtration and heating work, we can appreciate how science quietly keep us safe every day, from the baker to the breakfast table. That's all from me.